The topic today is function. That's the topic. And range. Another English word is domain. What else do I need? Okay, so now at this moment, forget about math for a moment. What is the meaning of the word relation or relationship? The English word, forget about math. So explain to me the English word relation or relationship. What does it mean? Who wants to go? What does relation mean?
It's like a app between someone.
Hold on. Laurel, please go. Laurel, go.
We can finish since she said it already.
Okay. Please repeat what you said. The first speaker.
I said it's like a bond you have between someone or something.
Okay. Connection between. Does it have to be somebody? It can be connection between two things, two or more things. Establishes a relation. So, what is the connection between something A and something B? So if it has to be human being A and human being person A and person B. So what's the relationship? What is relation? So what is the connection between you, see, and the person, or between one thing and the other? Okay, so how about the English word range? What does that mean?
The distance between two things.
What?
The distance between two things.
Okay, it could be. It could be the distance between two things. Yes. Who else? Range.
One day is hot in here. This is the hottest room. Another day is cold.
Okay. Joseph, your connection is not right. It's not good enough. I mean, we acknowledge what you made effort. Who else wants to try? Helena, go. What is the meaning of the word range? Helena.
The distance between two things.
The distance. Okay. All right. So I'll take it. Can it be also the difference between a smaller and the larger value? Can it also be that?
Yeah.
All right. Now, next person, Sharon. What is the meaning of the word domain? Domain. English word. Domain. We are talking about English now. Sharon. Okay, so now let's start with the one, the relation. Let's start with the relation. How many of you check the weather every single day? Maybe you check it through radio or through your app or through television or whatever. How many of you do that? Do you ever check the weather condition every day? So now let's consider days of the week. Let's consider, let me just draw something that looks like a box, and then let me draw another thing. It doesn't really have to be a box. It can be a circle. It can also be another box. Maybe let me use a circle this time around. Now, in one of these boxes, I'll be saying days of the week, like 1 day, 2 days, 3 days, the day 4, and day 5. Now, on this other box, I will be writing things like 35 degree, something like 60 degree, maybe 40 degree, maybe 45 degree. These are all degree in Fahrenheit. And so this box is representing temperature, numerical, which is what we just did. And then these are numerical values we just created here. See, these are numerical values. Okay. And then a third one is graphical. And then the fourth one is algebraically by an equation, which is what we did when we started. Number 4, algebraically, you see, and that's by equation. In this particular relationship, in this particular function, we started with algebraically.
You go back down.
Eh?
You go back down. I wasn't there right now.
Yes. Is that what you want?
Oh, never mind. I'm done.
Okay, so we started with algebraically by writing a formula because it's already known. It's an established fact that circle and area are related somehow, and their link is the circumference, no, the constant pi is their link. Okay, so we have formula, we have algebraic, we have verbal, we have actually covered the four. We have done verbal, we have done numerical, graphical, algebraic by formula. Okay, so now I have given you two examples. I have given you two examples of a system that can represent a function. So now, since you're using a pencil and paper, here's what I want you to do. Draw a line that links this radius to this area, but make sure it has an arrow on it. Draw another line that links this radius, this one, to this area. Just make sure it has an arrow on it. Draw another one. Don't mind how messy your drawings are or how your systems are. It doesn't matter. What matters is you're trying to link two. So draw another one that links this one. It has to be a straight line. And draw another one that links, cuts across. Okay? Does it make sense now?
I guess.
All right. Okay, so now that we have seen how to represent a function, the next thing we are going to do would be, in your own paper, write a real life situation that creates a function. So write an example of a real life situation that creates a function. Write a real life situation that creates a function. I've given you two examples. So based on the examples I gave you, think about it. Use 1 minute to think about it and use 30 seconds to write it down. Time now is 1:12. And our class ends 1:40. So we have almost how many minutes? We have just about 30 minutes. Write an example of a real life situation that creates a function. Everybody, you must write something because I'm going to call your name. I'm going to call everybody's name. We have how many students now? We have now. Okay, now let's. Sometimes when you plot the graph, it doesn't really give you a particular shape. It doesn't really give you a particular shape, but nonetheless, it is still a graph. You can plot a graph that looks like this, and then you have your point here, you have another point here, you have another point here, you have a point here, you have a point here. You know, you just have a bunch of points. So what type of graph is this? What type of graph? It has a name. It starts with S.
Oh, what?
It starts with S. What type of graph have I just
Scatter
plotted?
plot.
So it doesn't really give any particular shape or any straight line or anything like that. The numbers are all over the place. It's called scatter plot, and they are like that. Okay, numbers all over the place. So it's called scatter plot. And sometimes the relationship can be straight. Sometimes it can be a curve. Now let's consider so testing for a function represented algebraically. We have actually tested it. We actually tested it right here. We tested all these algebraic functions. This one is actually, that's testing. We started with radius and then we had area and then we plotted something. That's actually testing. But let's test again using another relationship and see if it is a function or not. So now let's see. So the question is going to, it looks like this always. Determine whether each equation represents y as a function of x. Determine whether, let me write it down. Determine whether, the equation I'm going to write down, whether each, there are two equations here, but let's just work on one. Determine whether each equation, whether this equation, whether the equation, I'm going to write just one. X squared plus y equal to 1. So do you think this represents a function? Actually, let me write the second one. The second one is negative x plus y squared equal to 1. So now it says determine whether each represents y as a function of x. Each equation represents y as a function of x. Now let's look at the first one. Can you analyze the first equation? Can you solve for y in the first equation? Yes or no? Yes or no? Can you leave y on the left side and then every other thing on the right side?
Yes.
Yes. So that's what you need to do first. So you can change this. You can change this to say that y is equal to negative x squared plus 1. How about the second one? How about the second one? So what that means is, for each value of x, you are going to have a corresponding value of y. This is what it means. So in that case, is it a function or not? Remember,
can you repeat what you just said? I didn't hear you.
I said, in considering this equation now, this one that we just changed. I said for each value of x, you are going to have one corresponding value of y. And then my question was, is that correct? Yes, it is correct. It is correct. It is correct, because you can just draw something that looks like this, create a table. You have your x here, you have your y equal to negative x squared plus 1. You have 0, 1, 2, 3. All you do is you plug in these values to generate the value of y. So once that can happen, then for each value of x, there's a corresponding value of y. That's a conclusion you can easily draw. Now, on the other hand, look at the second one. Look at the second one. This second equation. If you want to solve for y, you are going to have y squared equal to 1. Maybe x plus 1. Because if you transfer negative x to the right side, it becomes positive. True or false?
True.
Yeah, so then for you to solve for y, you are going to get y equal to plus or minus square root of x plus 1. So that means in this particular case, this one, if you have one value of x, you are going to have two values of y, which can be either positive or negative. So if we have, let's say if we create the same table, a similar table that we created there, if we recreate it right here, and we have our x, y, z, we have our 0, 1, 2, 3, and even 4, and then we have our y is equal to plus or minus square root of x plus 1, and then these are x. So if for the first value, you just put x equal to 0, 0 plus 1 is 1, square root of 1 is 1. So you have value 1 and 1, and then, I'm sorry, negative 1. Second one, you do 1 plus, yeah, 1 plus 1 is 2, square root of 2. So you are going to have plus square root of 2 and minus square root of 2. So this one is not a function. This one is not a function. This one, not a function. The first one is a function. This first one is a function. The first one, a function. And okay, so now what I'm going to do right now is, since I have introduced this subject to this extent, I am going to give you some problems that you need to solve, and then I will create a Google Classroom where you are going to upload your work, yes, including the notes and everything. So let me see what I can give you. Okay, so here's the question. Question number 1. I'll write task. Please show me work. Task. I'll write evaluate the following function or find the function value if possible. Find the function value if possible. Find the function value if possible. So here's the relationship. VR is equal to 4/3 r cubed. And then you have, this is problem number 1. This is number 1. So you have 1a. 1a is VR. B is V3/2. Then C is V2R. Who remembers this formula? Who remembers this formula? What is it called? This formula has a special name.
Circumference.
Circumference of what? Who agrees with that? Circumference. Do you agree? Circumference of a circle is C equal to 2 pi r. This one is volume of something. This is volume of a sphere. So another function that we can work with is, another function we can work in is number 2 is use this formula. F of x is equal to square root of x plus 8 plus 2. This 2 is not inside the square root. Just note that this 2 is not inside the square root. And then the values of x are, f of x, f of negative, this is -8. This is -8, and that's A. B is f is 1, and C is f. Okay,